Welcome back to All This Math. This is Professor Parker. Today we sporting the Black Power t-shirt with a lot of people that we should definitely be familiar with. You know, you can check out some of these faces and some of these people as you watch this video. If you haven't already, please subscribe to the channel. Subscribe to the channel, you know. Also, after you subscribe, make sure you hit the notification button so you can get notifications when new content comes out. All right, so check this out. I was in a tutoring session yesterday, right, with this young sister, and she had a homework assignment, and she put me on to a method of converting repeating decimals to fractions, a method I had never heard of before, right? So as I tell people all the time, you know, a lot of my teaching ability comes from my students. Like I learn a lot of things from my students. Now, she learned this from her teacher. Her teacher assigned her homework where she had to use this method, and then she told me about it. And when I finally got the hang of it, I was a little excited. I was a little intrigued, you know what I mean? So, because I like finding out, you know, new different algorithms and everything and, you know, different ways to do stuff, especially because I've been in a situation before, I'm going to tell you, where I had to teach people, like, you know, teach students like how to convert like 0.3333 repeating to a fraction. And I really couldn't break it down for them, like, in the best way. Like, yo, why does that equal 1/3? You know what I mean? Like, besides just having that memorized, the fact that it equals 1/3. And I don't like to, you know, I like for there to be like a method, you know, to the madness of mathematics, right? So the young sister, she put me on to this algorithm that I'm going to show you how to use in a couple of these examples up here. I got 0.3 repeating. Of course, when you see that horizontal bar, that means that that number repeats like forever, right? It goes on 0.3, 3, 3, 3. And also that bar is important because we have to keep in mind that this is not 3/10, right? If that bar was not there, then it would be 3/10. But because that bar is there, that means that this is not 3/10. All right. Same thing with here. We got 0.54. So that means it's going to repeat as 0.54, 54, 54, 54, 54, on and on and on forever. And then down here, this is a little different because you notice that the bar is over top of the 6 and not over top of the 1. So that 1 in the 10th place remains there, and then these 6s go on forever and ever and ever and ever and ever. 0.1666666666666. All right. Now, the only thing I don't like about this method, well, actually, it's not. I don't have a problem with the method. My issue is that I don't understand. I know that it works, and I understand the algorithm and the procedure, but I don't understand quite yet why it works. It hasn't really hit me yet. You know what I mean? Like, that light bulb hasn't gone off yet as to like why it works. So I gotta holler at some of my other people, some of my colleagues, some of my, you know, brothers and sisters out here that also get into this math like that, and talk to them maybe, and maybe they could tell me, you know, like why it works or like what's the science behind it. You know what I mean? So anyway, so let's get started. So you start out with this decimal 0.3 repeating. All right. First, you want to identify, because we're going to use algebra. We're going to use an equation. We're going to create an equation. But before we do that, we're going to write this as x equals 0.3. And I'm going to write some more 3s just to show, kind of round it off to like the 10th, 100th, 10,000th place, right? I'm going to just round it off like that, right? Now, because this repeating decimal is in the 10th place, I'm going to also find what 10x is. Now, if I know that x is this, 10x is just 10 times this, right? So 10x, I'm just really just sliding the decimal point over one space to the right. So I got 3.3333. And I'm going to just add an extra 3 over there, right? Now, this is where the magic happens, right? You create an equation. Your equation is like this. 10x minus x, all right? So you start with that expression. And then we want to say, okay, well, what's that equal to, though? 10x minus x is equal to this number minus this number, because that's 10x and that's x, right? So this is equal to this, take away this. So now, then we're going to solve for x. Watch what happens. We got 3.3333 minus 0.3333, right? So now we got that. Now, let's simplify this. What's 10x minus x? That's 9x. So now we got 9x right here. And then we got 3 point, all these 3's, minus 0 point, all these 3's. We're going to end up with a whole number. That's the key. On this right-hand side, we want to end up with a whole number, right? So we end up with 3. 9x equals 3. right? Now we're just solving a simple equation in algebra. We want to isolate the x. So I'm going to do the inverse of multiplication because 9x means 9 times x. Since we're doing multiplication, the inverse is division. That's how I get rid of this 9. So I'm going to divide by 9 right here, and I'm going to divide by 9 right here. Boom, boom, x equals 3/9. But wait, always reduce fractions whenever possible. Whenever it's possible, always reduce your fractions. So the greatest common factor between 3 and 9 is 3. So that means I'm going to divide each of these numbers by 3. 3 divided by 3 gives me 1. 9 divided by 3 gives me 3. So that's like proof that 0.3 repeating is equal to 1/3, right? I like this method. I'm hype about this. That's why I had to make this video today. I just learned about this yesterday. I'm already up here making this video right now, right? So x is 1/3. So instead of just saying, well, memorize, we should memorize some things in mathematics, a lot of things in mathematics actually, but this is a way to like really show that this does in fact equal this. All right, so let's slide over here. 0.54 repeating, okay? So let's identify this as, okay, let's have x equals this. So let's do x equals 0.5454. Now it repeats, right? So I want to show that it repeats. All right. I can do four digits. 4 digits is cool. Now, but here's the difference with this one versus this one. With this one, we found 10x. The reason we found 10x was because that repeating decimal was in the 10th place. So in order to convert this into a whole number, we had to only multiply by 10. But this repeating decimal goes to the 100th place, right? So I need to actually multiply this by 100. And again, like I haven't really fully figured out all the inner workings of this. So like my explanation is not going to be as thorough as it will be once I understand this better. But for now, like just rock with me, right? So then we do 100x, and that's going to be 54.5454, right? And again, remember on the right side of this equation, my goal is to end up with a whole number. So because I'm going to do 100x minus x, I'm going to do this number minus that number. I'm going to end up with a whole number. If I did 10x, then I wouldn't have ended up with a whole number. Well, I won't end up with a whole number, I should say, once I do the subtraction. So let's set up the equation. The equation is going to look like 100x minus x is equal to 54.5454 minus 0.5454. See what we got right here? 100x minus x equals 54.5454 minus 0.5454. All right. So on the left-hand side, what's 100x take away x? That's going to give me 99x. So I got 99x. And then on the right-hand side, I need my whole number. So 54.5454 minus 0.5454 is going to leave me with 54, right? Now I'm solving my simple equation, right? I got one step left. I do the inverse of multiplication because 99x means 99 times x. So the way that I'm going to get rid of the 99 in order to isolate the x is by doing the division. So I'm going to do this. I'm going to divide by 99 and I'm going to divide by 99. Boom, boom, x. Now, I could reduce this because these two numbers, this numerator and this denominator, they have a common factor. The common factor is 9. Check that out. 54 divided by 9 gives me 6. 99 divided by 9 gives me 11. So that means that equals 6/11. And now, if you want to ever check your work, just pull that calculator out, do 6 divided by 11, and you should get 0.54 repeating. You should get 0.54 repeating. All right. So that's what this is. This one was x equals 1/3. All right, now this one is the tricky one. And again, like I said, like I don't fully understand like all of the inner workings and all the logic behind why this algorithm works. So because we have to do this one differently. So I know how to do it, but I don't fully know how to understand why it works, and that kind of makes me uncomfortable. But You know, like math is a process. You know, even learning math is a process. Sometimes, like you first learn something, you don't fully really grasp why it works. You know how to do it, but over time and continually like working through problems, things kind of occur to you and reveal themselves to you, and you're like, oh, that's why that works, right? But you want to get to that moment. That's why you can't give up in math. You got to keep pushing and keep doing the work, keep practicing the problems, so you can get to that moment where you're like, oh, bet. Now I see why it works now. Okay, cool. All right, so this one. X is going to be 0.1, and then the 6 repeats. The 1 does not repeat. The 6 repeats. You can see where the bar is, right? So I got 6, 6, 6, right? I'm going to do 0.16666, right? Now, I'm not going to multiply by 10x because the 6 is in the hundredths place, right? The 6 is in the hundredths place. So just like here, the repeating decimal goes to the hundredths place. I'm going to find 100x. So now I got 100x, and that's going to give me 16.666, right? And I got, you know, that. Well, let me do 4. Let me do 4 places. Let me do that. All right. But here's the thing. If I set it up like 100x minus x, I'm not going to end up with just a whole number. I'm going to end up with a decimal. Because 16.6666 minus 0.1666 doesn't give me a whole number. I need to end up with a whole number. So what I got to do is I got to find out what 10x is. And I think it might have something to do with the fact that the number in the 10th place does not repeat. So maybe that's why I have to subtract 10x. Maybe that's why. I got to keep thinking about that. But I know it works though. I know it works. But again, I'm trying to get to like why it works. You know what I mean? So at any rate, 10x would be 1.6666, right? So now we set the equation up. My equation is going to be 100x minus 10x. I'm not really worried about x in this particular problem. I'm going to do 100x minus 10x. And then what's 100x? This right here. 16.6666 minus sign. What's 10x? 1.6666. Boom. Now, over here, left side, what's 100 minus 10? 100 minus 10 is 90. So now I got 90x. Then over here on the right side, I got 16.6666 minus 1.6666. That's going to give me a whole number. That's going to give me a difference, which is a whole number. So this gives me 50. 90x equals 50. Oh, what am I talking about? Not 50. I'm tripping. That's going to give me 15. Where I get 50 from? So 90x equals 15, right? 90x equals 15. Now, we're going to finish solving the equation. We're going to isolate this x. We're going to divide by 90 on the left side, and we're going to divide by 90 on the right side. So we got x equals 15 over 90, but we can reduce that. We can reduce that, right? The greatest common factor between 15 and 90 is not 3, it's not 5, it's actually 15. 15 divided by 15 is 1. 90 divided by 15 is 6. So that leaves us with 1/6. And this is correct, you know? And again, like I kind of had to, like yesterday, like with my student, I had to go through like some kind of inquiry type of method. Whereas like when we did 100x minus x, it didn't work out, right? When we did, at one point we did 10x minus x, it still didn't work out, right? I'm pretty sure. But what I realized is that, and what I told her was like, listen, if we did it the right way, the way that we'll confirm that we did it the right way, because I'm also a big advocate of students checking their work, right? So we can like, you know, feel empowered and we don't got to wait for nobody else to tell us that our answer is right. We know it's right because we did the math, right? We can just do 1 divided by 6 and see what we get. So if you put in a calculator 1 divided by 6, you will get this. You will get 0.16 repeating. You will. So that's proof that, you know what I mean? Like the answer, like to this, 0.1 with the 6 repeating is in fractional form 1/6. So, you know, that's just something that, you know, I just learned about yesterday. Shout out to Iman, my student, that put me onto this. And, you know, I hope y'all learned something. I hope this was valuable, a valuable use of your time. And again, if you have not subscribed to the All This Math YouTube channel, please subscribe. Not only that, turn on the post notifications. Not only that, tell somebody else about all this math in the YouTube channel, right? Tell somebody else, because we got a lot of valuable content on here, and I want y'all to do well in math, right? Just tune in, pull up a video, whatever you need. You know I got it. Algebra 1, Algebra 2, geometry. I'm about to come through with some calculus videos. Get at me. We out here. All right? So with that in mind, as I said, thank you for tuning in. And please do remember that there's all this math all around you. Peace.